lesson, we're going to talk about classifying quadrilaterals. Now, a quadrilateral is a four-sided polygon. Quad, meaning four. So if you ride a quad, it's four wheels. Anything with quad in it is going to mean four. Quadruplets, four babies. Quad meaning four. So four-sided polygon, four sides, four angles. Some quadrilaterals have properties that classify them as special quadrilaterals. So we're going to talk about what those special quadrilaterals are in this lesson. Now, just to note, this is something we're going to be working with further on in the lesson, but I want you to have this. Quadrilaterals can have more than one name because the special quadrilaterals sometimes share properties. A lot of times adults get into trivia arguments about some of these things, and so it's going to be really good for you to know for sure and be able to back yourself up with some solid definitions. So here are some examples and definitions of these special quadrilaterals. We're going to begin with the parallelogram because everything after the parallelogram uses the parallelogram, and you'll see what I mean. This is a drawing of a parallelogram. Now, it's not perfect. My drawings aren't normally perfect, but you get the idea. The definition of a parallelogram is a quadrilateral that has opposite sides that are parallel and congruent. So this side is parallel to this side. And when we're talking about items being parallel, I like to draw arrows on them so you know this side's parallel to this side, and this side is parallel to this side. Okay? So opposite sides are parallel and congruent. So this side is congruent to this side, and this side is congruent to this side. Now, also, what is true with parallelograms is that opposite angles are congruent. So this angle is congruent to this angle. They're both obtuse. And this acute angle is congruent to that acute angle. So all of those things are true for a parallelogram. A shape that's seemingly simple has a lot going on in it, and all of those items are going to be apparent in our other quadrilaterals. So, there you go. Now a rectangle. The definition of a rectangle is nice and short because a rectangle is a parallelogram, but it has four right angles. So if you'll notice, the opposite sides are parallel because of the right angles. So that makes it a parallelogram. And because of the right angles, these opposite sides are parallel. They also happen to be congruent with each other. So these opposite sides are congruent, and these opposite sides are congruent. So because all of those things are true, and opposite angles are also congruent, well, that's definitely true because they're all right angles. This is a special parallelogram. So all rectangles are parallelograms. Okay? You know what a rectangle is. You've worked with it since preschool, but now you just know the specific definition. Then we have a rhombus. Now a rhombus looks like a parallelogram, which it will, because the definition of a rhombus is that it is a parallelogram with four congruent sides. Now this doesn't say anything about angles, except we know that a parallelogram has opposite angles that are congruent. So these two angles would be congruent, and these two angles would be congruent with each other. These two are congruent, and these two. But what has to be true is that all four sides are congruent. So it can be, and usually when we're talking specifically about a rhombus, we're talking about this square that looks like it got shoved a little bit. So if you can picture this being shoved, obviously it doesn't have the four right angles, which we'll talk about in a minute, but it does have four sides that are congruent. So there you go. Now a square is, again, a parallelogram with four congruent sides and four right angles, which are congruent. So this is just like the idea of the rectangle, except it goes beyond that to say, yes, it's a parallelogram with four right angles, but it also has four congruent sides. So we could say that a square is a rectangle with four congruent sides. But either way, four sides are exactly the same, four right angles. So a square is also a rhombus. But we'll talk about that in a minute. Then we have two even more special quadrilaterals. One that we won't actually use very often, but I wanted you to have it in your notes because it is a quadrilateral. It doesn't get mentioned in textbooks. It's not something you're really responsible as a 7th grader, but why not have it in your notes? The first is a trapezoid. Trapezoids you are very responsible for. And the trapezoid is not a parallelogram because it has exactly one pair of parallel sides, not two. Exactly one. So here, these two sides are parallel. These two are not. These two parallel sides make this a trapezoid. And that's it. Here, you have, this is more of a regular trapezoid. This is an irregular trapezoid, but it's still a trapezoid. It's a 4-sided polygon in which this side is parallel to this side. Okay? And in a trapezoid, I didn't put this, but the parallel sides in a trapezoid are called bases. And you'll need that for a later lesson. So even though in both of these examples, the parallel sides are horizontal, I could draw a trapezoid that looks like this. And it's not very good, sorry. But this side is parallel to this side. That's a trapezoid. And the bases are standing up. That's okay. So just keep that in mind for later. Kind of cool. And then the last quadrilateral we're going to talk about, just for definition purposes, is a kite. Now a kite looks like an old school kite, one that you'd be flying with ribbons and string in the middle of spring and you're happy to be outside or at the beach, right? Now a kite, the definition, is that it has two pairs of adjacent congruent sides. The word adjacent means next to. So this side is congruent to this side, and they're right next to each other. See, they're touching each other. This side is touching this side. Because they're congruent, and then these two sides are congruent, and they're touching each other. They're right next to each other. That's what makes this a kite. Okay, pretty simple. So we're going to just do a few identification examples, and we're going to give all of the names that apply to each quadrilateral. This could get tricky, but we can totally do it. When you first look at this quadrilateral in example A, it looks like a diamond, right? It's obviously a square that's tilted on its side. So because I've just said square, what makes it a square? I've got 4 right angles and 4 congruent sides. So it's certainly a square. Now because it has 4 right angles, it's also a parallelogram, right? And if it's a parallelogram with 4 right angles, it's also a rectangle. And if it's a parallelogram with 4 congruent sides, it's also a rhombus. So this square is all of these things. This is always going to be true for squares. Squares are really special like that. Okay? So a square is a parallelogram, is a rectangle, is a rhombus. But it's not always true the other way around. Because if we get to B, you notice that you have this quadrilateral and it's got 4 right angles. Now these two sides, they're opposite sides, they're congruent. These two sides are opposite and they're congruent. Because these angles are right angles, this side is parallel to this side. And this side is parallel to this side. So one name we could give to this is a parallelogram. But I think the best name we can give to it would be a rectangle. Okay? These two sides are congruent, and then these two sides are congruent. All right? Lastly, we have this crazy looking thing. Now I know, the height has been drawn in, and I know it's the height because it's kind of a dotted line, and it gives me the right angles. Height is always measured perpendicular to the base. And if these two sides are the bases, I know they're the bases because they are parallel to each other based on this information. So if I have one, are these two sides parallel to each other? They are not. So the only name, quadrilateral-wise, that we can give to this shape is trapezoid. Okay? Then I have a few fun questions for us. Come on, there we go. These are some true or false questions, something for you to think about beyond the lecture. All squares are rhombuses. Now, I don't know, the textbook said rhombuses. I like to call them rhombi. I don't know if that's actually the correct plural form. I think it is. But it was published as rhombuses, so I'll trust that, and I'll also trust what I think is right. Rhombi or rhombuses, I mean, you would call the plural of octopus, octopi, so I'm going with that. Are all squares rhombuses? Well, squares have 4 congruent sides, right? And so do rhombi. So we're going to say this is true. You should be thinking through this with me, not just waiting for me to answer the question, right? All rectangles are parallelograms. Well, look back at your definition for rectangle. A rectangle is a parallelogram. So, are all rectangles parallelograms? Yes. This is true as well. Now, all squares are rectangles. Well, all squares have opposite sides that are congruent. All squares have 4 right angles. And this is definitely a rectangle, so the answer is true. Now, are all rhombuses, or rhombi, rectangles? Well, I don't think so, because if you remember the definition, or you remember the example I drew of the original rhombus, it did not have all right angles, did it? Now, all of the sides were congruent, but if it's tilted and doesn't have right angles, it is not a rectangle. So if all rhombuses are rectangles, that is false. And this drawing right here is a good reason why. How about this? Are some trapezoids squares? Well, all squares have to have 4 right angles. And I'm pretty sure I drew a trapezoid in which there were not right angles. But what about some? Could you draw a trapezoid that's not a square? Well, trapezoid has exactly 1 pair of parallel sides. Exactly 1. Every square will have 2 pairs of parallel sides. So no, this is false. This is never going to be true. Ever? And how about this? Some rectangles are squares. Some. Well, this rectangle that you're used to is not a square, but this is. And it is a rectangle. So the answer is true. Some rectangles are squares. Are all rectangles squares? No. But some, yes. So there you go. Quadrilaterals.